Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine you're an AI that can write code, but the moment the code base gets big, tests fail, files are hidden, you freeze. That's the problem this paper tackles. Today's story is about daVinci-Dev Agent Native Mid-Training for Software Engineering by Ji Zeng and Pengfei Liu. This paper isn't about writing one function. It's about teaching AI how to behave like a real software engineer. Traditionally, models learn from frozen code, isolated files, finished commits, perfect answers. But real developers don't work like that. They search files, read context, edit, run tests, fail, fix again. Training on static snapshots teaches models what code looks like, not how software gets built. This creates a brutal mismatch. Training shows the final result. Deployment demands the entire journey. The agent never learns how to decide where to look or how test failures guide the next step. This gap is called distribution mismatch, and it's the villain of our story. Unquote. The authors define an agentic task as a loop: localize files, read context, edit code, run tests, revise. Not once, but over and over. An agent isn't judged by a single output. It's judged by whether the tests pass. Unquote. Most prior work tries to fix this after pre-training, supervised fine-tuning, reinforcement learning, expensive rollouts. But post-training can't invent abilities that aren't already there. If the base model never learned agentic behavior, you're just polishing a statue with no arms. Unquote. The key insight: teach agent behavior earlier, during mid-training, not by isolated subtasks, but by full realistic workflows. This is called agent native mid-training. First dataset type: contextually native trajectories, built from real GitHub pull requests. Each sample includes the issue, relevant files, file contents, commit by commit edits. Localization and editing stay together. No Oracle shortcuts. No perfect file lists. Just like real work. Unquote. The pipeline is massive. Millions of pull requests, top repositories. Python focused on multi-language. The model even rewrites vague commit messages to explain what the developer was thinking. Result: 68.6 billion tokens of agent-shaped supervision. Unquote. But context alone isn't enough. So comes the second dataset. Environmentally native trajectories. Here, an agent runs inside real Docker environments. It edits files, runs tests, sees failures, tries again. No simulation, no fake feedback, only reality. Here's a crucial twist: they keep failed trajectories. Why? Because debugging is the job. Passing runs teach success, failing runs teach recovery. Together, real engineering behavior. Unquote. They start from Quen 2.5 base models. Not even code is specialized. Mid-training uses contextually native PR data, environmentally native execution data. Only after that comes supervised fine-tuning. The payoff is huge on SWE-Bench Verified. If we model 56.1%, 52B model 58.5%. State of the art among open recipes with less than half the tokens of prior methods. Unquote. Something unexpected happens. The model gets better at human eval.
Eval plus.
Scientific reasoning like GPQA. Learning to debug code teaches general reasoning. Engineering sharpens thinking. The scaling curve is clean, more agent native data, better performance. No saturation yet. And GitHub has hundreds of millions of pull requests. This path is just getting started. This paper changes the question: not can AI write code, but can AI work like a developer? daVinci-Dev shows that if you train on real workflows with real context and real failure, you don't get a code generator, you get an engineer, and this is just the beginning. Unquote. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.